Okay, students, actually the section four is about why we are learning logarithm. Do you remember what purpose logarithm was invented? To change the operation from multiplication to addition. Do you understand? From the multiplication to addition, that is actually the basic purpose why mathematicians invented logarithm. And then please look at this graph. After the scientists researched the data and plotting the data on the grid, and as you can see, the graph looks like the exponential graph. Can you see that? But the thing is, exponential graph, it has property to increase very fast at some point, right? Very fast at some point. It's very difficult to plot this graph on the grid because the increasing rate is faster and faster and faster, so that the space is not enough anymore at some point. So William, please read this part. It is
difficult to draw an exponential curve that best fits the point, but there is a clever trick that turns this curve into a straight line.
Yes. So for example, there is an exponential model. Exponential model is always written as n equals n0 e to the power of kt. Please remember this formula, okay? That is called exponential modeling. It's familiar, right? But now it's time that you need to remember the exponential model form. So what is N0 represents, guys? The initial value. N0 represent initial value.
Equals 0.
Yes. Initial value means when t equals 0. And the k, if k is positive, it means that exponential growth. If k is negative, it means that exponential decay. It was defined from the beginning of section C. And then students, it is modeled as n equals n0 e to the power of kt. And if we put logarithm, what base should we choose in this case? Base. E, thank you, E. And then, so ln n equals ln n0 times e to the power of kt, then always the rules of logarithm, if it is combined in one logarithm, you can separate them. If it is separated, then you can combine them. Thank you. But since in this case, it is combined, right? So let's separate it. This is multiplication, right? Then ln, please tell me. N0 plus ln e to the power of kt, and of course we can move kt to the front. Very good. And then ln e is the value of 1. Therefore, you can write this one as ln n0 plus kt and ln n. Now, please look at the shape of this one. ln n0, it's just number, right? It's just a number. K is independent value, independent variable, independent change. And ln n, we treat it as dependent variable. So if we think ln n as y, and then the form is, it's just a number. Let's say c plus kt. Guys, it looks like y equals c plus mx. Can you see that? Can you see that? So we can change this exponential graph to straight line graph by using logarithm. Do you understand? Okay. Then straight line graph, it's very easy to treat when we solve those questions or when you interpret models. That's why mathematicians invent logarithms. To interpret it as a straight line graph, because we all know that addition is easier to treat. then the multiplication. So example 8.8. Okay, Jason Tao, please read this question.
According to the model, n equal to c to the power of t, where m is the mass in grams, t is the current in seconds, and c and t are constant.
Wait for a sec, student. So they say radioactive decays, right? Decays. Let's analyze this model first. So when y equals a to the power of x, there are two types of graph. If a is greater than 1, and then this graph is increasing, exponential growth, right? When a is less than 1 but greater than 0, then the graph of a to the power of x should be decreased, exponential decay. Do you understand? And then you should ask me, Miss Yang, the model, the previous model, it was written as n0 times e to the power of kt. You told me when k is the negative and then it's exponential decay. Why? Because you told me just now that if a is less than 1 but bigger than 0, then it's decay. What's the difference? Can you see the meaning is the same or not? The meaning is actually the same. Let's say that k is negative. K is negative. It means, let's assume k is -1. Do you understand? Then we can rewrite this model as n0 e to the power of negative t, right? Which is n0 times e -1 to the power of t. How we convert e to the negative power of t? Sorry, e to the power of -1. How do you convert it? And 1 over e to the power of t. Do you understand? And 1 over e, this value is actually less than 1 and bigger than 0. Do you understand? That's why when k is negative, e to the power of k, this value is automatically becomes the value between 0 to 1 to make it as decay. Do you understand? So let's go back to this question. Since it says it's decay, so what's the range of B, students? What's the range of B? Less than 1 over and then more than 0, okay? A physicist, Jason Tao.
The physicist measures the mass over time and plot the point on the graph with t on the horizontal and log m on the vertical axis. The line of x is has equal log m equal to 1.3 minus 1.8t.
Estimate.
Estimate the value of c and d.
Okay, guys, so it means that we need to put log to both sides. So what base are we going to choose?
Log.
Yeah, base 10, because there is just log, right? Log. So log m equals, guys, log c times b to the power of t. So you can separate them as log c plus log b to the power of t and move t to the front. Do you understand? And please compare this one to the given equation. Log m equals 1.3 minus 1.8t. If you compare these two, you can see log c is equal to 1.3. Can you see that? Log c equals 1.3. And then since t is here, log b should be equal to,
1.8.
not just negative 1.8. Log b should be negative 1.8. Therefore, c equals 10 to the power of 1.c. Do you understand? and B as 10 to the power of negative 1.8. By using your calculator, please give me values. Take out your calculator.
1 sheet and then
1,
C equals to 20.
20.
So be around there.
Which one? Last two steps. These two. Okay. It's the definition.
20.
It's 10. Base is 10. So 10 to the power of 1.3 equals C. Do you remember this one? 10 to the power of negative 1.8 equals B.
0.01.
I just, without mentioning it, I just converted directly.
0.016.
Sorry, again,
0.016.
0.016
0.016.
and C
20.
20. Okay, students. So value of C is similar to 20, or is you can estimate it as 20, and then B, you can estimate 0.016. Okay, Hayden, please read this orange box.
Y equals 8 to the power 10 to log y equal log 8 or 10 log 8. The graph of log
Guys, this one is very natural. We just did it, right? You put log to both sides and then separate logarithm, move power to the front. And then please keep reading it.
graph of log y against log 8 is straight line with gradient and y equals at log 8.
Okay, guys, so log y equals log a plus n times log x. If you cannot see it, it's a straight line graph clearly, then you can substitute this log y as big Y equals log A. Log A is just a number, right? Plus n times. You can substitute log x as big X. Do you understand? Then it looks like y equals c plus mx. Can you see that? Therefore, this is a straight line graph with gradient n and y-intercept log A. Students, do you understand?
Yeah.
I know it's not familiar, but you can solve this question. Not familiar. Ethan, please read example 8.9. A scientist.
Scientist thinks that area is created by equation for y equals ax to the power of 10. She collects the data and plots a scattered graph with log x on the horizontal axis, log y on the vertical axis.
Wait for a sec. So you should put log to both sides. Do you understand? Then log y equals log a plus, we can skip this part. So n log x. Can you see that? And then please keep reading it. The
points following is shown gradient 2.6 and log y intercepts negative 0.9.
So students, simply substitute 2.6 as gradient, which is here, right? 2.6. And y-intercept, negative 0.9. This one is y-intercept, negative 0.9. So you can rewrite this equation as log y equals negative 0.9 plus 2.6 log x. And then the final step, find
Find the values of a and hence write an equation for y in terms of x.
Okay, so firstly, we need to find the value of a and n. And then log a equals negative 0.9. Therefore, a equals what is the base? 10, right? So you can write it as 10 to the power of negative 0.9. Understand? And then n is as it is, just 2.6. Okay? Then they ask you to bring back this equation, the original one. Okay, 2.6 move back here as index. So log y equals negative 0.9 plus log x to the power of 2.6. And then log a, this one guys. So log y equals, instead of negative 0.9, you can write it as log 10 10 to the power of negative 0.9 plus log x to the power of 2.6. Guys, I wonder if you understand this part. If you understand this part.
Log 10, the log 10, log base 10.
Yeah.
is equal to
Yes.
1.
So for example, if there is number 2 and I want to make this number by using logarithm, if I chose log 4, and then it's gonna be 2 and log 4. Do you understand? So you can change it as log 4 and 4, move it to index square. Okay? So in this case, negative 0.9 should be equal to log A. Understand? Then it's gonna be this one, negative 0.9, actually log 10, because the base is 10. Therefore, you can rewrite as log 10, move this one as its power, negative 0.9. Can you see it's the same process? Okay.
Log base 10.
Mm.
Log base 10 is just 1.
Yes. Okay, students, therefore, log y equals, since they are separated, you can make it combined with one logarithm, 10 to the power of negative 0.9 times x to the power of 2.6. Right? Then you can cancel log from each side. Therefore, y equals 10 to the power of negative 0.9 times x to the power of 2.6 is the original model. And then you should estimate this number by using your calculator, students.
0.13.
0.13,
13.
thank you. So it's y equals 0.13 times x to the power of 2.6 is the answer. Guys, is this exponential models or not?
Yes.
What do you think? Is this exponential model or not?
No,
Why?
negative.
Not because of negative. Please bring back your memory. X should locate as. Thank you, Wasi. Thank you, Wasi.
You can speak in your low. Better.
70% in next step, okay?
We got.
Y, it should be y equals a to the power of x. X should be here, students, that's our power. Then we can call it as exponential function, okay? But x is located here in the base, so that we cannot call it as exponential function. But anyway, logarithm can make this complicated function as easier one, the straight line graph. Because it always can make us convert from multiplication to addition. Understand? Okay, students, I'm going to give you some time to solve question 1 and 2. Please solve these questions now by yourself.